Okay, this is our last page of our review problems for our SIG test. This is topic 29, and basically this is working with the Pythagorean theorem. So the big issue, and this is where the typical problem you're going to see is one just like this very first one. We're going to use the Pythagorean theorem. You just got to be really careful with this term here. So the two sides that are connected by the right angle, I'm going to take x squared plus 14 squared. Those two are together. The one that's opposite the right angle, the one that's not connected by it, is by itself. It's opposite the other two, so it's on the other side of the equal. That's going to be x squared plus 14 squared equals x plus 9 in parentheses squared. Now what we need to do is need to be able to square out x plus 9. So, a couple different ways. One way is you could make it by the box method. So I do x plus 9 times x plus 9. X times x is x squared. X times 9 is 9x. X times 9 is another 9x. 9 times 9 is 81. So I got x squared plus 18x plus 81 is what I have on this side. There's a shortcut too. First term times itself, x squared. Multiply these two together and double it, 18x. Last term times itself, 81. Okay, 14 squared is 196. Subtract x squared from both sides. I get 196 equals 18x plus 81. Subtract 81, divide by 18. You could leave it as 115 over 18, or you could punch in your calculator, you get 6.389. On this second example, we have x's on each of the sides. So again, these two are connected by the right angle. So x squared plus, in parentheses, x plus 3 squared equals x plus 6 squared. So I have x squared, x plus 3 times x plus 3. So again, you can use like a box method right here, or another way of multiplying them out, you can use FOIL. I'll do it up here. X plus 3, x plus 3. First, x times x gives me x squared. And I do x times 3. So it's basically doing the distributive law twice. That's 3x. Insides, 3 times x. Another 3x. 3 times 3 is 9. So I got x squared plus 6x plus 9. Or the shortcut, first term times itself, multiply these two together and double it. Last term times itself. So I'll use that shortcut for this one. First term times itself, x times 6 is 6x, doubled, 12x. 6 times 6 is 36. Well, I move everything to one side so I can factor it. I can subtract x squared from both sides, but I still have this x squared. Subtract 12x from both sides, gives me negative 6x. Subtract 36 from both sides. 9 minus 36 is negative 27. When I factor it, two numbers that multiply to give me negative 27, but add to give me negative 6, be x minus 9, x plus 3. Set them equal to 0, so x equals 9, x equals negative 3. Often the negative answer you see won't be possible. If I plugged in negative 3, this side would be 0, this side would be a negative. So that's not going to be possible. So the answer would just be x equals 9. On the last one again, the biggest part of the problem is just squaring these out correctly. So again, connected by the square root, by the right angle. So x minus 1 squared plus 6 squared. So x times x is x squared. We get negative x doubled is negative 2x. Negative 1 times negative 1 is positive 1. Plus 36 equals x plus 3 squared. First term times itself is x squared. Multiply these two together and double it. I get 6x. 3 times 3 is 9. Subtract x squared from both sides. So the x squareds nicely drop off. Then I get negative 2x plus 37 equals 6x plus 9. I'm going to add 2x to both sides, so I keep my x's positive. Subtracted 9. I get 28 is equal to 8x. Divide by 8. Get 28 over 8, which you could divide on your calculator or reduce it. You get 7/2. 28 over 8 is actually okay too. Okay, rewriting into radical form. The numbers out in front is not part of the square root or the radical term. So the bottom number, this little number right here, which is a 3, tells you the type of a root it is. And that number up here was a 5. So I've got the cube root of x to the 5th. That's the way it would be written. The 7's out here. This is the root. That's the power of the term on the inside. When I go to simplify this, I need to have sets of 4. Well, 16 is 2 times 2 times 2 times 2. I could take out a 2. I have 7 x's. 7 divided by 4 goes in 1 with a remainder of 3. So an x comes out. X cubed stays inside. So this is my remainder. I had went in 1 time and 3 remaining. 5 divided by 4 is 1. So 1y comes out with a remainder of 1. Again, back to writing in radical form. 8th root of x raised to the 7th. 6 is on the outside, not the inside. This one, I need to get sets of 3 to take something out. So 81 is 9 times 9. 9 is 3 times 3. This one's also 3 times 3. I need 3 in a set to get something out. So I could take out a 3, and 1 3 remains. Then I look at this, x to the 9th. Divide this by 3. 9 divided by 3 is 3, so I get x cubed. No remainder. 5 divided by 3 is 1 with a remainder of 2, so 1y comes out, 2 stays in. Make sure when you write your final answer, and I probably should make it really clear, it was 3x cubed y times, give yourself lots of space in this area. This is where you put what's called the index. That should be cubed, then I got 3y squared left inside. So it's clear that this is the cube root and not y cubed. Okay, our last of our topics is finding the vertex of a parabola by completing the square. And this is one of the main reasons why we learn how to complete the square. So to complete the square, my first step I've got to do is I got to get this stuff by itself. So I have a little error in here, I just realized. So when you go to do this problem, erase this. That's why we work in pencil, so we can erase. All right. So I have x squared minus 4x. I have to take half of negative 4, which is negative 2, squared. I added 4 to both sides. This makes this side y plus 11. This factors now to x minus 2 times x minus 2, or x minus 2 squared. Then I'm going to subtract 11. To find your vertex is what makes the square part of the parabola equal to 0. So if x equals 2, this part equals 0. So it ends up being the opposite of that number. And then when I plug in 2 into my equation, I get 0 squared is 0 minus 11. That's negative 11. So my vertex is at 2, negative 11. It's going to be the same as this number. So it's really easy to figure out the vertex once you get in the correct form. Okay, I want to get just my x's on one side, so I'll move the 26 to the other side, so it becomes minus 26. Half of 10 is 5. 5 squared is 25, so I added 25. Negative 26 plus 25 is negative 1. This factors now to x plus 5 times x plus 5, or x plus 5 squared, equals y minus 1. We add 1. So my vertex is at negative 5, again the opposite of this, comma 1. The last one, first thing I did is I get it back to the normal y equals form. So x squared subtracted 3x plus 12x plus 34 complete the square, I move 34 to the other side. So y minus 34 equals x squared plus 12x. Do half of 12, that's 6 squared is 36 added to both sides. Negative 34 plus 36 is 2. This becomes x plus 6 times x plus 6, or x plus 6 squared. Move 2 to the other side. My vertex is at negative 6, negative 2. Again, the opposite for this one, or what makes this equal 0, and then that term.